Identify the coefficient of the term that contains x to the fourth. So how many blanks would you have on this one? 7. Okay, I'm just going to do it this way. 1, 2, 3, 4, 5, 6, 7. So do you guys remember the numbers for the sixth row? Good. Okay. Do somebody, like, I have this row memorized. Do you guys have some of the rows memorized? No? Okay, I guess I'm a nerd. All right. So that's good. There you go. You remember some of them then. Okay. So this will be x to the 6th. This is x to the, and this is x to the 4th. So this is the term that they want because they want the coefficient of the term that has x to the 4th in it. So if this is x to the 4th, negative y is going to be to what power? The second. Okay, now again, you have to double check if your coefficient is positive or negative. So will this one be positive or negative? Positive, because a negative to the second power is a, so my answer is 15. Okay? Am I missing something? Okay. All right. 12, identify the second term of this expansion. So if I just do 1, 2, on the 5th row, my first two numbers are what? 1 and 5 for the 5th row. Okay, so the first one here, this will end up being 3x to what power? The 5th, and then this one will be 3x to the 4th. Very good. Which means that y will be to the first. Okay, so we're finding the whole second term. What is my next step for a popsicle stick? Connor, what's my next step? We're on number 12. What do I do to finish simplifying this? Yeah, so we have to make sure that 4th power goes to both of those. So what is 3 to the 4th power? 81, and then we have x to the 4th, and then we solve y. And so then when we multiply 81 times 5, what do we get? What is it? 405. X to the 4th, y. Are we good? Okay. Number 13, find the variance. Who knows? Oh, sorry, just kidding. If the variance of a set of data is 64, what is the standard deviation? Good, because your standard deviation is always the square root of the variance, and the square root of 64 is 8. Okay, 14, and pay attention. You guys are going to see questions like this a lot. Many trains passed through Fresno yesterday. A representative from the city counted the cars from each train. She reported 65 as the mean. So out of all the sets of trains that came through, the average of all of them that came through was 65. There are actually people that do this kind of stuff to see what is going on in the city, okay? It's actually a job. Okay. Then 6 is the standard deviation. Well, I'm sure there's more to their job than just that, but okay. Each train. Okay, so what they're saying though is that each train had 5 engines, and the engines were not included in the count. What would be the report if the engines had been included in her count? So what do we do for this? So what they're saying is that for the mean, they didn't count the engines. But if they had counted the engines, what would the new mean be? It would be larger, which would be, it increased by 5, so 70, because every train had 5 extra engines, okay? So the new mean would be 70. Now, I just want to show you something. Let's pretend that our range was originally 20 was the lowest amount of trains that came in, and then 40 was the largest. So from 20 to 40, what is that range there? 20. Okay, so now if we added in the engines, our range is going to change from 20 to 25. No, this is a pretend example. And 40 is going to change to 45 because we're adding 5 From the lowest and 5 to the highest. What's the difference between those? 20 again. So remember, standard deviation is kind of dealing with the distance between your smallest and your largest number. So you notice if I added 5 to my smallest and largest number here, it shifted, but the numbers in between are still 20. The distance is still 20. This is why your standard deviation is still 6, because your highest and lowest just shifted. There's still the same distance between the high and low number. Do you guys get that?
Yeah.
Okay, so this is the new answer. Yes?
So the mean goes up by 5, and the standard deviation stays the same?
Yes.
Would that be the same if it was like plus 8?
Yes. So basically, and we're going to actually talk about this a little bit later, but whenever you're just adding a number to your mean, they both stay the same. If you were multiplying by something, they would both end up changing. And I'll show you why in a minute.
I have a question.
Yes.
How do you know to add the 5 to the 65? Because all it says is she reported 65 as the mean.
So the mean was the average, okay? So let's just say, you know, her numbers were like 55, 100, and so on, okay? So what's happening is that each of these had an additional 5 that she didn't count. So this one changed to 60, this one's changed to 105, and like so on down the line. Well, if every single term in there added 5 to it, then that means that your mean is going to change by 5, because every single piece of data had 5 added to it. I can show you with like not using 65 because I can't like make up those numbers in my head. Let's just pretend we have the numbers 3, 4, 5, and 10. Okay, let's take the mean of this real quick. So 3 plus 4 plus 5 plus 10 is 22, and 22 divided by 4 is 5.5. Okay, so right now this mean is 5.5. Okay? Now we're going to say that each of these increases by 5, just like they did in here. So that means this will be 8, this will be 9, this will be 10, this will be 15. Okay? So let's go ahead and add these up. 8 plus 9 plus 10 plus 15 equals 42, divided by 4 equals 10.5. So do you see how my average increased by 5, which is what I increased each of these by? So basically, if you know the mean, if you know your mean, and they're saying that each one is added up by some number, your mean will just add up by that number.
Okay, so my question was, how do you know to add the 5 to the 65?
Because it's each and 5 and
Because your mean is changing by 5. Just like here, this is the mean I made, right? My original mean. And then I said each of these increased by 5. If I add 5 to this number, I get 10.5, right? And then I was showing you mathematically how if I add 5 to each of these numbers and actually do the actual mean, I get 10.5 as well. Okay? So what's happening is they're just adding 5 to everything, which means your mean would increase by 5.
So would it always be like consistent, like the same thing?
Yes.
No matter what number it is, it'll be.
Yes, if they're telling you the mean is a number and that everything in your original set of data is increased by a specific number, then your mean will also increase by that specific number. Yeah.
what was the thing is if you multiplied it, you said something?
If you multiplied, and we're going to actually do an example later, but let's just pretend. Okay, so let's say my high number or my low number is 2 and my high number is 10. Okay? If I told you, and then, you know, we'll say that the mean is 6. Okay? So that means there's like other numbers in here, okay? But what is the range right now between these numbers? Okay, range is 8. Okay, now if I increase these by 2 or whatever, our mean could increase by 2. This will make more sense when I show you a different thing. Okay, but if I say, so if I added by 2, this would be 4 and this would be 12, but my range is what? Okay, but if I said that I multiplied it by 2, so what is 2 times 2? 4. And what is 10 times 2? 20. And what's the range now? 16. It increased. So if you're adding by numbers, your mean increases, but your standard deviation stays the same. If you're multiplying by a number, both of them increase. So you see how this range increased from 8 to 16? So that means that your standard deviation would increase along with your mean. Yes?
Okay, so increases, would it be like the original number was multiplied by 2?
No.
Oh.
But they're just going to ask you a question like, what would happen? And you would say it would increase. And you could, if you had to, you could go through and multiply every piece of number or a number in a set of data if they gave it to you and find the new standard deviation. Okay? All right. Can we move on for a minute? And we'll talk about this again a little later. Okay. So, we decided that this answer was right there. Okay. Identify the variance of the set of data. Who remembers how to find the variance? What do we do? First step is take the average. So we add 9 plus 3 plus 7 plus 12, and what do we get for our answer there? Sorry. What is it again? 81? No, 31? 31, and we divide 31 by 4, and you get 7.75 is your mean. Okay, what do you do next in order to find your... You subtract them from your original set of data. So we go 9 minus 7.75, 3 minus 7.75, 7 minus 7.75, and 12 minus 7.75. And when we do that, I get 1.25, negative 4.75, negative 0.75, and 4.25. Is everybody okay with that step? Okay. My next step on this equation is to do what? Jet. Very good. Then you square each of these numbers. Okay, when I square each of those numbers, I end up getting 1.56, 22.56, 0.56, and 18.1. My next, oh, Vienna?
We can't round the decimals. We have to keep it just how they are.
I would, because it makes it more accurate. If it's like a huge long number, then you can round them if you want to. But if it's just like 1 or 2 decimal places, I would keep it. Okay, so what's my next step now, Helena?
Well, you already squared it, so you sum it up and divide it.
Yep, you add it all up and divide it by 4 again. You're taking like the mean or average again. So when I add all those numbers up, I get 42.78, and we divide it by 4, and that answer is 10.7. Okay, so where people sometimes make mistakes is once they get the 10.7, they just automatically take the square root. But if you take the square root, you're actually finding the standard deviation. So make sure you pay attention to what the question is asking you. Okay, number 16. Compare the 2 sets of data. Okay, so we need to figure out which of these statements is true. So first I'm going to do data set number 1. Okay, whenever you're doing that, the first thing you need to find is the mean, right? So in order to get the mean for number 1, I add them together. 1 plus 3 plus 11 is 15. And 15 divided by 3 is 5. So that mean is 5. Let's go ahead and look at number 2. Number 2, the mean is 18. 18 divided by 3 is 6. Okay, so looking at my answer choices right now, the 2 sets of data have different means and standard deviations. Do they have different means? Yes. So I'm going to circle A because A could be an answer. The 2 sets of data have the same mean and standard deviation. Do they have the same mean and standard deviation? No. B cannot be an answer. Data set number 1 and number 2 have the same mean. No. Data set number 1 and number 2 have different means, but the standard deviation is the same. Well, we don't know. So right now my answers could be between A and D. So I have to find the standard deviation. So what do I do now once I have the means? Subtract them. So I have 1 minus 5, which is negative 4. 3 minus 5, which is negative 2. 11 minus 5, which is 6. Nope, sorry.
When you're subtracting those numbers, it doesn't matter which way you subtract it, right? Because in the end, you're going to square root it.
Exactly. Square it, yeah. Okay, so now we square each of these numbers, and we end up getting 16, 4, and 36. And then we have to take the average again. So we add all those up, and we get 56 divided by 3, which is 18.7. And in order to find the standard deviation, we square root that. And the square root of 18.7 is 4.3. Okay, so now I have to do the same thing for my data set number 2. Okay, so we already found that the mean was 6. So now I'm going 4 minus 6, which is negative 2. 6 minus 6 is 0. And 8 minus 6 is 2. Then we square each of these numbers, and we get 4, 0, and 4. We add them up, and we get 8 divided by 3, which is 2.6. We square root 2.6, and we find that the standard deviation is 1.6. So are their standard deviations the same or different? Different, because one was 4.3 and one was 1.6. Therefore, both of the two sets have different means and different standard deviations. The answer is A. Okay, on 17, the only answer they're basically asking you for is, it says state the steps needed. Basically, I just want to know what is the one step you do in order to find the standard deviation. Square root of the variance. Okay, last one, number 18. They are telling you that the mean is 78. They want you to find the variance to the nearest 10. So in order to find the variance, we have to subtract. 85 minus 78 is 7. 72 minus 78 is negative 6. 76 minus 78 is negative 2. We then square each of these, and we get 49, 36, and 4. In order to find the variance, I add all those up, and I get 89 divided by 3, which is 29.7. Do I take the square root of that? No, because they didn't ask for standard deviation. All right. Questions?